So in this session, I'll introduce you with one of the most classic analysis in Pine Core, the building damage. I'll start with some introduction. We'll briefly touch upon what is fragility curves and what are fragility mappings. We'll talk about building inventory data set and how to convert it into in accordance to the format that our Pine Core building damage analysis accept. And then we'll configure the damage analysis and run it. Once we see some output, I'll show you what are some easy data post process we can do and some visualization. So first, I'm going to talk about what fragility curve is. So damage analysis use fragility curve sets to calculate the limit state and damage state. And in InCore, we have a fragility services that you can store your fragility curves there. And we also use something called mapping. So mapping is basically records the relationship between what inventory will use what fragility curves. So an example would be like, say you have a group of buildings. Some of the building is 4-story high and others are 3-story high. So the 4-story high will use a specific fragility curve and the 3-story ones will use another one. So this mapping helps you to capture the relationship between that. Since due to the time limit, I won't talk too much about the details of them, but we have a tutorial here. If you click this link here, we have a specific tutorial designated to teach you what are DFR3 and how to create your own, mapping in those. So for fragilities, there are a few ways you can use them and create them. One way would be you can look at what we currently have in the DFR3 viewer. So you can access DFR3 viewer by going to our website. And here the drop down, after you log in the drop down, you can select DFR3 viewer. And then here are a bunch of filters to help you narrow it down. Like say you want fragility. I want to see all the earthquake related fragilities. And then I want to further narrow down to all the buildings. And you'll see from those lists, you can select any one of them. And this is the representation of the curves. You can preview them. You can hover over them and see at each hazard intensity corresponding to the probability of exceedance. And here are some more like details about the parameters. And more importantly, you can copy the ID. And once you have the ID, there are places you can plug in to use the Pine Core, where I will demo in a bit. And another tab is the DFR3 mapping. Similarly, you can select and filter and then copy their ID, and then you will be able to use Pine Core to import this DFR3 mapping. So this is a screenshot. This is one way you can directly use what's existing there. You can also upload your own. You can follow the tutorial. There will be instruction like what format you need to form your fragility, and then you can upload to the services, and then in exchange you will have an ID. But in this, so in this tutorial, and the third way would be like you can create your own on your local machine without interacting with our services. But in this tutorial, I'll show you the most easy one. We'll just preview one which already exists in our system. So to read a fragility curve set, in Pine Core, we have defined a few classes to represent the interaction with our services, as well as represent the curve itself. So you have to import them first. This one is helping you create a client to talk to our services. Once you have this client, you can input it in our fragility services that helps you to talk to specifically our fragility services. And once you have them, you can use the ID. You can copy the ID from the viewer and put it there. And then on the fragility service, there is a method called get DFR3 sets and set, and then you run this, it will fetch the information back. And then further, we instantiate a class called the fragility curve set. So this way, you will create a variable called fragility curve set that is incompatible with our Pine core analysis. So if you look at what they are, this fragility curve set will have 3 curves. And what are those 3 curves? Furthermore, we have a Pine core visualization package called Pine core Vis, which I will also talk more in the later session. But for now, it has a class called plot util, that stands for utility class for plotting. You import it this way, and then on the plot util, there is a method called get fragility plot. Then you put the object you just constructed here inside of it, and then you can give it a title. And this is the fragility curves we just created. Moving on, now we have the fragilities. The next part prior to run a building damage is to actually create a inventory data set. The inventory we have must follow a certain format. We call it column schema to be able to be compatible with our analysis. The reason we have a format is because some of the columns are important and will be used in the analysis. So those must be present in able to for the analysis to run. And we have gone through several iterations. We have V4, version 4, version 5, 6, and 7. So this shows you a version 7 table schema looks like. I can pick a few columns to tell you what it means. Like, for example, GUID means the unique identifier for a inventory, for a building in this case. And for example, archetype is the building structure architectural type, which is also important because this field will decide what fragility curves to apply onto. And other things, for example, year built, the year of structure was built is also important. So whenever you are creating your own data set from your own machine, you need to be more careful of following our schema definition. So in this tutorial, I will show you how to create your local data set from a CSV file. There are also other ways to create data set, which I put them in the optional section later. So for now, let's just try with a local CSV. It should be included in your tutorial. We have a Ergo Memphis Hospital. So I have all the columns that is for version 7. From there, from a CSV, we want to use a library called GeoPandas to convert it into shapefile first. So GeoPandas is an open source project that is very similar to Pandas, if you're familiar with that. It helps you to create tabular data frame to hold your geospatial data. And also there's method inside of it to convert it into a shapefile. So, and then once you have the shapefile, then we will need to convert it into a PyIncore data set object for it to be able to work with the analysis. So following this step here, first we import this data set class from PyEncore. And then step one would be we first import pandas and then GeoPandas. So pandas, this read CSV will directly read the file in CSV format and populate it into a data frame, like a plain data frame. And then once you have the data frame, you use the GeoPandas library to create a geodata frame. Notice here, this is the projection. We're using this projection. And then here you need to specify which columns you're using to create the geometry, like what's the longitude and what's the latitude. Once you have those, it will populate a geodata frame object. And then there is a method called toFile to help you save it to the shapefile. If I run it, you'll see I have 5 shapefile created this way. And then, as I mentioned before, there's a column called GUID, which is very important because it helps us to differentiate different buildings. So GUID is a 16 digits unique identifier. If your data set already come with the GUID, also the column is named GUID, then you don't need to worry about it. But if you don't, we also have a very convenient method in our PyEncore utility class to help you add a GUID to an existing shapefile. So here you run this add GUID. This is your old shapefile, and this will be your new shapefile. If you run it, you'll see I create additional shapefiles that contains the GUID. And last step is once you have the shapefile, you also need to convert it into a PyEncore dataset object for analysis to know that we can directly use it. So if you run the dataset from file, here you put the shapefile name, and here you put the data type, and then you will construct this. Oops, I think I didn't import it here. And then you have local buildings. And I want to emphasize a little bit on what a data type on this field. And this is quite important because each analysis have a predefined sets of data type to be able to work with that analysis. You can find this information in our menu, in core menu, and then you can find the corresponding analysis. In our case, this is building damage. If you look at this page, and it will show you the input data set here, and here is the type. Now you will know that the building damage is compatible with version 4, 5, 6, and 7. So, yep, just a side note. Okay, going back, I also included 2 options, 2 optionals. So similar to fragility, you are able to, we hosted a data services, and with a bunch of data already existing, you're welcome to pick from our data services to use the data already existing. The way to browse through them is in our website. You can go to data viewer, and here you can filter through a bunch of types, like say bridge, or like building, or building damage, and say this hospital. If you click it, this is the metadata. This is the information about this data set. You can download this information. You can download the data set itself, all those shapefiles, and you can preview it. It will show it the dots on our on the maps. And then you can copy the ID. And then this ID could be used in PyEncore. So this blob, if you enable this blob in code mode, you'll be able to run it, and you can put the data ID you selected here, and then it will use this method called from data services. You'll be able to construct the same building variables that we created. It's the equivalent of the local buildings we just created. And furthermore, if you have a local dataset shapefile, and you say, I want to share it with the community, or I want to upload to the in-core data services, this is the blob of code that you can use to upload. And then you can, in exchange, you'll get the ID, and you can then use it the same way as how you would choose a data set from our services. So yeah, feel free to try those out on your own. Yeah. Okay, now we've prepared our data set. Moving on, we can actually try to configure the building damage itself. So this is the table I just copied from our manual. It tells you what are the input parameters and the input data sets, and what are the output data sets. I would try to explain what the building damage is trying to do. So first of all, we have a set of buildings, and based on their geolocations, we are able to, we need to decide what hazard we want to use. We support a bunch. We support earthquake, tsunami, tornado, hurricane, and flood. So given the latitude and longitude, we're able to get the hazard intensity value of that location. And once we have the hazard value and we know what fragility curves to use, then we can calculate the the probability of exceeding each limit state, along with the probability of damage state. I'll explain what are the input parameters one by one. So the result name is the output name you want to give. It is in the type of string. And then you can select what hazard it is. Here are what we supported, together with flood as well. And for the hazard ID, we have a third viewer called hazard viewer. So here is the place you can select a bunch of hazard. And for example, in the previous session, we already covered tornado. You could preview tornado, and you can also copy the ID here. Okay. So the fragility keys are not required. We have some default putting there. If you want to know what it is, please refer to the tutorial that's specialized in DFR3. There are more explanations there. And if you want to use liquefaction, you can set this flag to true, but the default is false. And if you want to use hazard uncertainty, you can also set this flag to true, but the default is false. And last one is the number of CPU. This is for parallel computation. The default is 1. You can put any number, but it will use the maximum number of CPU that on your machine. So this helps speed up the calculation process. And for input data set, we already created the buildings. This is one. And another one is DFR3 mapping. I'll show you an example of how to do that in the below cell. Last, those are the outputs. We will have 2 output files. One is in the table format. It's in CSV. It will have the column of GUID as well as the damage state and limit state. And the next one is sort of metadata, like we call it supplementary data. It will show you what the hazard value has been generated for that building at that location, as well as other information such as which fragility curve has been used. Yeah, let's do it. So first, you import the building damage from the PyIncore analysis building damage. And then, like I mentioned before, you can put down the hazard type, and you can browse through the hazard IDs and pick the one that you want to use for your analysis. And then the result name, you can name it whatever you want to. And last is the mapping ID. And you can select the mapping ID by looking at the DFR3 viewer, there is a mapping type, a tab. You can copy and paste, put it here. So here is the code to create a mapping set. So you first, you use fragility services, you put the ID here. It will fetch, it will talk to our services and fetch the information. And then you instantiate a mapping set object and put it as this variable. So yeah, now you have a mapping object. This is how you configure this analysis. First, you instantiate a building damage object. Then you use the method called set input dataset to put the building. This one is what we just created locally. And this one is the mapping we just created as one cell above. And then you kind of port those data set into the analysis. And set parameter is the method that helps you set the input parameters. So here, if you run it, oh, oops. I need to run every cell, I keep forgetting, okay. If you successfully run it, it will say true here. If not, you'll see the error message like I did. And then this one-liner is actually how you run the analysis. You say building damage analysis, run analysis. Yeah. And then if it succeeds, you'll say true here. Then let's take a quick look at the output. I would like to highlight this line because this is important. So this is the method that helps you to read a output from the analysis. You run this get output data set, you give it the name, and then because it's a CSV, then we have a method to display it in data frame. This is important, especially this part, because like our Pine Core analysis is able to chain with each other. Once you finish building damage, you might want to take the output of a building damage to run something further downstream. For example, like you want to see what's the Monte Carlo simulation of this specific damage. Then this way you will get the output of it, and this will be the new input for another Pine Core analysis. So that's why I want to highlight this line. And then you will see what's the content of it. And meanwhile, in the directory where you run this analysis, you will see two files being generated. One is the tabular form, the CSV data, which has the GUID. We have 22 buildings, so we have 22 unique GUIDs. And then we'll have 3 limit state and 4 damage state, with a additional column called hazard exposed. This one indicates if this location is exposed to a specific hazard or not. Yeah, this is the one output. And another one is the JSON, in JSON format, that has the supplementary information about the damage. So you'll have this GUID indicates which building it is and what is the fragility curve being used, and what is the demand type, what's demand unit, and what is the hazard value on that building. Yeah. So after you have the output, another common thing to do is post-process your data and visualize. Similar to the things we showed before the damage analysis, which is like pre-process the data, post-processing is very flexible. And here we are just giving you a few ideas. You should be able to run your own, come up with your own post-processing suits to the needs of your research. So this is just for some inspiration for you guys. One of them, one common one is joining data set. For example, if we look at the output, it only has the GUID and the damage state, but doesn't have much information on what this building is, like what's the characteristic of this building. But we happen to also have the shapefile that have a lot of information of the building. So a powerful tool to use is to actually joining these two tables so you have like a more holistic view of the data set. So here's how you do it. This is your damage results in one data frame, in this EQ building damage data frame. And then you can use GeoPandas to load your shapefile in and put it into another data frame called building GDF. And then you can merge these two tables by their intersection column, which in this case is the GUID. So I first select only 3 columns because the shapefile is pretty large. I select GUID, structure type, and geometry, this 3 field from the shapefile. And then I want to merge it with the damage output on the field of GUID. And this way, you have a table that has all the information you defined here. So this is one. And second, because we're using pandas and GeoPandas, they already come with a few very easy to use, powerful tools to help you gain some quick insight on your table. One of them is called Describe. This one is on the pandas data frame. So we have this data frame here, this one. Let's see, what could we learn about this column LS0? So if you run this command, I'll give you a quick summary. There are 22 buildings, so the count is 22, and it will tell you what is the average, what's the standard deviation, what's the minimum, what's the maximum, and like, etc. And another thing would be sort. You can sort on one specific column, or you can sort on a bunch of columns at the same time. You can specify their orders if you want them to be descending or ascending. So in this, this line of code is telling you, we're selecting, first of all, we're selecting DS3, this column. We're also selecting the structure type. We want to sort based on these 2 columns. For DS3, we want to sort it based on a descending order. That's why I'm putting a 0 here. That's meaning descending. And for the structure type, we want to sort them with a ascending order. That's why I'm putting it as 1. And if you run it, let's see. Yep. And last is group by. Group by helps you to group a specific column so you can see the characteristic within this column. So in this example, we are grouping by structural type, and then we are able to see what's the average for each of the column with a specific structure type. So if you run this line, it is doing, you select the structure type, you put this as an index, and then how do you want to aggregate it? Then you select DS0. You say, I want to get the average for this column, and similar for those. And the last column, the total count, I want to do a count. I want to know how many of the buildings are with this structural type. So, and with a bunch of renaming, we'll have a nice table looks like this. It will tell you more information within a specific structural type. Moving on to visualization. Pandas already come with a few very handy visualization methods. For example, this one is plotting a horizontal stacked bar chart. You run this command and you put stack equals true. then you generate this table. You can further set the title. You can further set the titles, the X label, and you can put a nice legend here. Yep. And also Pandas comes with a method for you to plot a histogram called hist. So you can specify the bin size, you can specify the figure size, and probably a lot more parameters if you look at the documentation for Pandas. Yeah, then you will have a histogram plot for a DS3 column. Moving on, we have a PyEnCore visualization package for to work with our Python module. So it already packed with a few common visualization methods you could use for your research. I'll show you quickly how you can find more information about PyEnCore Viz. So in your user guide, you'll see a PyEnCore reference. This will show you the detailed definition of each PyEnCore class. This example will show you how to plot a geospatial map. You first import PyEnCore Viz GeoUtil class, and you import it as GeoViz. And then you can put down the earthquake ID, the hazard ID, where you can find it on the hazard viewer. And then there is a method called plot earthquake. You put the ID as well as the client name. It will show you this graph. This is one. You can also plot a map with a dataset object. Remember, we created the local building dataset in the beginning of the session. So you use this method called plot map. You put the dataset in, as well as you specify what's the column you want to color it with. And then you can set the flag of category. This will put all those information on the map with a legend indicate what's the structural type. And then moving on, you can also, this is plotting a PyEnCore dataset object. You can also plot a raw geodata frame. You have a shapefile, we have a shapefile previously, and we were using the GeoPandas to load them into a building damage data frame. So this is what it is. So you can also directly plot them like this, in this fashion. So we set the base map as false. That's why you won't see a map underneath. But you can also turn the map into true, and you'll have a very similar graph to the previous one. And last, we have the capability of helping you plot an interactive map. So this is plotting a heat map directly from the GeoPandas data frame. So you put the GeoPandas data frame in, and you specify which column and what's the radius, what's the blurry effect, and some names and multiplier. Then you have an interactive one. You can zoom and zoom in, zoom out. Take a look. That's all I have. Thank you.